Alright, g'day guys. Little quick repair job today. I'm in my trailer box and this is my battery station, and I made this support for it. It's actually a metal plate, and I 3D printed these sort of support brackets and arms to support, because I wanted it to swing down if I ever needed to fit something something large in here. And it was supported by the arms down onto these 3D printed brackets. But as you can see, this one is broken. The way it's broken suggests to me, and the amount of force that was on this particular one, because it was holding a lot of the weight by the look of it wasn't because it was hit. It was because of the weight down on it, the way it's broken down here off the bottom, rather than teared just from the side. So today I could just 3D print another one, but because it looks like there wasn't a lot of infill on that one. It's quite a large infill on it. So I could 3D print another one with less, or make it solid, which would probably work. But because this is taking a lot of weight and a beating, and it's already broken once, I think I will actually make these out of aluminium, because I have the drawing from CAD for these, so I've just printed out the drawing, and I'm going to make these out of aluminium, which shouldn't be too hard. I'll keep these plastic arms because they seem to be working quite well. I mean, the trip we did was about an hour and a half long, and it could have broken anywhere in between leaving and returning from that. So this one arm is holding this up for what could be about 3 hours of driving. So when I put the second one back on, I think it's going to be more than capable of supporting it. That was the weak point, obviously. And if we change them to aluminium, that should fix our problem. All right, so just unscrew these. And now we have a template to check against the one I'm going to machine. And I'm going to replace both of them. I'll make both. I'm going to replace both. Alrighty. Let's get back into it. Okay, so here's the drawing for the part we're going to make. It's 45mm long, 25mm wide by 24mm high. The actual 3D printed part has got some radiuses on it. It's got 12.5. I'm not going to be measuring that. It doesn't need that. I'm just going to be filing that till it looks like, it's of a similar radius. It's not important. The reason why it's set 12.5 was because that was a good mate for the mating part for it. So I'm just going to eyeball it. It's not important. The hole is important, 8.5. I'm going to get an M8 bolt that goes through there. So that is important for clearance. And same as the holes here. The width is more important because they're already drilled on the trailer box, and I want to match them. They're very important. That's 32.33. I don't know why that came like that. Just did. So we also need a 12mm for that piece in the middle of where the mating part slides over. 12mm wide. And these other radiuses are just broken edges. No, that was more for strength. Radius is in there. It's for the 3D printed part would be stronger. With this stuff, don't have to worry about that. It's just going to be a square edge. There'll be a small radius in there from when it was machined. That's about it. So we just need some stock. I've got some 25 by 25 aluminium. We'll just cut it off 45, a little bit more, maybe 46, 47 mil wide, and we'll machine it up to dimension in the mill. All right, off to the bandsaw. Okay, as you can see, the remnants of machining in the last one, there's a fair bit of metal to be removed from this to turn that into that. Okay, so this is basically some 25 by 25 aluminium, and it's about 45 millimeters long, and so we don't need a lot of finish sizing to do, just a little minimum cleanup on the edges, and that's purely for aesthetics. It's no surface, as it's a bracket in the end. But we like to make it as good as we can. So I'll run the mill past the side of it to clean it up, because we've got the saw markings, even though that one's already been cleaned up. I think it's the size on the end. I've already done that because I put them both in at the same time. When I was machining the side of that one, because it was on the edge of the vise, I used this one on the other side to even out the vise, so I got even clamping. So that's why that one's already finished to width. So we basically just have to remove all this other material. And you just think, okay, we'll just put it in the vise, hold it from the bottom, and just go clean off the sides there. The one problem with doing that is that is only 5 mil thick, and I had great difficulty in trying to get that to stick up above the jaws, because that's mainly because of this vise. I don't know why. It is a great vise, but anyway, the biggest problem I've got with this vise is that this jaw is lower than this jaw. I don't know why, but there's about a mil difference between this jaw and that jaw. So I can get this to the point where I have clearance above that jaw, but then this jaw is higher, so the cutter's going to hit on there. Anyway, I'm going to have a bigger play around with it, because when I machine this one, I turned it on its side like that, and I machined it like that, and then I turned it around that way and machined it that way. It'd be a lot easier if I could just do it like that, but as you can see, you've only got 5 mil, and if I get 3 mil grip on that bottom jaw, which is about the minimum you want, that means I only have, if I get 3 mil grip on this jaw, that means I only have 2 mil on that jaw. So not the best place I want to be. So I think I might just do it again on the side like that, and that way, because I tried and just didn't fancy it, because I knew it was going to rip it out of the jaw. There's just not enough room to grip 2 mil at the back here. So that's another problem. And that's mainly with my equipment. I don't know why that's that way. There is no adjustment on that. And look, I'd love to just machine that down a little bit, but it'd be hardened steel, and I think I'd destroy my cutter before I got anywhere near it. I may one day remove it and see if I can get it surface ground down, that extra mil, the same as that one, would be good. I'll just show you. We'll wind this in. You see the height difference? Yeah, it'd be great if I could get that machine down to the same height as that. But that's another time. All right, so I'm going to get this set up, and yeah, we'll get into starting to machine it. All right, back soon. Okay, I'm just going to touch off. And there we are there. And now, while I'm at it, I'll touch off on the other side. Okay, I'm very sorry I've made a bit of a boo. I forgot to start recording, and I've already machined one side. I've only got one more pass to do, just to take off a millimetre. This is 25mm width wide, and the height that I need is 24mm. So I I have to take 1mm off the top of that, which means I've got to go an extra mil here to bring this to 5mm and still have 90mm there. So we'll bring it back, take that extra mil. And now we'll check. Just under 5mm there, and we've got just over 20mm there. So that side's done. It's 16.5. So I've got another 0.1 to take off there. Okay, now that side's all done. Just get a bit of a clean off here. Remove it. Okay, so we're getting there. Now we just have to do the other side. Again, very sorry I forgot to press record on that side, but we're going to just mirror what we did on that side on this side. So we're on there, but I'm going to have to touch off on the top again and touch off on the side again to reset the DRO to get these depths right again, because I didn't record it last time. So we'll get into that now. I'll just bring it in. And also take it down because the depth's changed. making contact now. Get rid of some of this swarf. Or chips, as a lot of you like to call them. Just give it a quick. Oh, actually, I made a bit of a mistake because I have to. This is actually 25, and I need it to be. I've made it to be 24, so I have to machine another millimeter off the top of the top section, but it means I need, because I need 19 mil depth here, I need to go an extra millimeter, and I only need to 19, so I'm going to have to go another millimeter there. So let's go into 20. Okay, so we'll just check thickness there. Yep, just a touch over 5 mil, which is not an issue. We should have 19 mil depth there. Well, actually we've got 20 mil, which is expected because I have to machine 1 mil off the top of there to make the overall height 24 millimeters. So in all respect, that part of it is done. We can remove it from the vise. Again, this two-stage vise, watch it in play. Now, as I undo it, it's still tight, and then I'll get to a point where it'll come from the second stage back into the first stage. There it is there, and it releases. Really nice vise, and a great feature for the era it was manufactured, back in the late 60s. Okay, so there's our part, and as you can see, we've still got a little bit more to do to it, but it is beginning to look like what we need. So now we need to relieve these corners. On my drawing, I radiused this at 12.5 mil. Now I could go ahead and do the file these off, but I just opted to put these 45s on the corners here to remove them, because like I still got plenty of meat there, and this is only holding up 13 kilos, maybe 14 with the base of the battery and everything on it. So the plastic ones held the weight, so these shouldn't have any trouble. Okay, so I'm going to do that. Yeah, so we'll get into the next section of how we machine these corners, and at the end we'll drill the holes and that hole at the end of it. All right, we'll start getting set up for that. Alrighty, got the part set up on some parallels, and I'm going to do the two mounting holes here. So I've got the edge finder. I'm going to edge find here and there. Then I'll use a DRO, which will give me the center, which should be 6mm, and then I will come out half the hole with spacing, which I've got on the drawing there, which is an absurd dimension of 32.33mm, and that'll be halved down to 16.1515, something like that. Okay. Start this up. 0 to X. X half function. And now we'll just bring it over to 0. That should put us directly over the part. Zero to Y. Okay, Y half function, and now we just simply wind that in till we hit the 0. Now we hit center. Okay. Now we need to drill a hole of 4.5mm. Okay. And we'll just check those holes line up perfectly, and they do. I don't know about you, but I don't think it gets much better than that. Okay. So now we need to add this hole, and then we'll work on cutting the corners off. So this hole, I think I'll just put this in there like such, with a parallel only on one edge. So we'll remove that parallel and sit that in there like that. And wind her in. Alright, now edge finder. Okay, now we're set up in the y-axis and the x-axis for that center. Just going to drill it. Okay. Yeah. Hole is drilled. And where's our part? Let's see if we can. Yep. And they line up just by eye through there, so very similar height. Like I said, it is not important. There's no precision really to this at all, apart from these two dimensions, because I want it to line up with the existing holes that are there. This hole does have some sort of precision, obviously, but I've got a bit of a flex in the plate. So now we'll just set up, just get rid of these corners. Okay, this is what I used to machine the 45 corners on. I made this a long time ago when I was an apprentice, and I really at the time thought, what will I be using this for? And all these holes I had to drill, but it's come in handy today. So basically it sits inside there, and I put, because I want it in the center, parallel there, it sits on the parallel. And you sit the part in there, and then you need a way to clamp the part down, so that's where these come into play. Just screw them in. Actually, before I do that, I want to take that millimeter off the top, because that's going to influence the corner. Let's do that. Start it up. Touch off. 0 to Z. Again, a millimeter. And we're going to climb cut all the way around, so hopefully that reduces all the burr. Okay, remove that. There. And now we'll sit this in now. Okay, so now it's just a matter of hitting that depth that we want there. Okay, part's in position, and we're just going to take a light cut off the corner, and then we'll come down till we hit the depth we're after. There we go. Okay, and now we'll flip it over and do the other side. Okay, so flip the part around. And clamp it back down again. Just centralize the part again. Okay. Now, we'll just take her in. Take a cut. I'll just centralize the cutter over the part. And there you go. We'll remove the part, just break the edges, and that'll be ready to then be installed. There we are. The two mating parts, which are more or less identical. The only thing left to do is to just put a chamfer on there, just file these edges a little bit so they're not sharp, and round over the corners, and that's done. So I'll do that, and then we'll catch you back at the trailer box and we'll put it in. Okay, I hope you can see. Nuts on. There we are. All good. Okay, so there we are. Our hinges are installed, well, our brackets for our supports are installed, and that's it. Job well done. Alright guys, thanks for following along for that. Like I said, not a very difficult part, but yeah, it did offer some challenges for the work holding for sure. And that V block with all those holes in it finally came in handy. So if you're an apprentice and they get you making all these little nifty little gadgets, which is part of your learning process to learn how to machine, don't throw them away, keep them, because they will come in handy one day. There'll be that odd part that you're trying to machine and you're just trying to think of a way to hold it, and you, lo and behold, you'll have it in your arsenal already. Alright guys, thanks for watching, and catch you next time.